Put just 23 people in one room. A shared birthday becomes more likely than not. That sounds impossible, so let us test it. This is the entire crowd, only 23 guests. Each person brings a different story and a birthday. Nothing about the group looks large enough for a coincidence. Write every birthday on a calendar card. Could any two cards show the same date? Make your guess now. 5%? 10? Maybe 20? There are 365 possible days, so a match feels unlikely. The real probability is already 50.7%. With only 23 people, a shared birthday is more likely than not. The arithmetic is correct. The surprise comes from our mental picture. We usually compare one chosen person with everyone else in the room. That creates only 22 comparisons, which still feels manageable. But the birthday question does not choose one special person. Every guest can form a pair with every other guest. As those connections appear, the number of comparisons grows rapidly. 23 people create 253 possible pairs. 5 people produce 10 pairs, while 10 people already produce 45. Adding people grows the crowd slowly, but grows the pairs much faster. By 23 people, the network contains 253 possible pairs. Assume birthdays are independent and equally likely across 365 days. What is the chance that every birthday in the room is different? Once we know that probability, one subtraction gives the chance of a match. The first person can have any birthday without creating a collision. All 365 dates are still available, so the first step contributes a probability of 365 over itself. The second person must avoid the one date that is already occupied. The third person must avoid 2 occupied dates, leaving 363. Each additional guest has 1 fewer safe date to choose from. We multiply all these shrinking probabilities together. The product is about 49.3% for no shared birthday. Subtracting from 1 leaves 50.7% for at least one match. The probability curve rises gently at first, then becomes surprisingly steep. At 23 people, it crosses the 50% line. At 50 people, the chance of a shared birthday is already about 97%. This collision pattern matters far beyond birthday parties. Computer systems assign identifiers and compress information into limited spaces. When many items enter that space, duplicate values become increasingly likely. Back at the party, 23 people still look like a small group, but they create 253 different pairs. That hidden explosion of comparisons is the birthday paradox.